So like I said, we're going to jump around a little bit. I kind of just pulled like 3 topics from Unit 4 that you will for sure see again in Calc, which is why we're covering them. The first is this one, which is parametric functions, okay, which is 4.1. So a parametric equation is defined as a set of equations that express a set of quantities as explicit functions of a number of independent variables known as parameters. These equations will introduce a third variable, t, that represents time. So parametric equations are 2 equations. That one would be like an x equals and one would be a y equals, but it also puts it in terms of t. So parametric will form a shape, and we're going to learn that you can actually graph these like they are rectangular, like your typical functions. But the idea is that there is a pattern over time, and that's what t is. So if you look at the graphs on the next slide, okay, on the left is your parametric function. On the right is your rectangular. Now they look almost identical, okay? The overall shape is the same. But if you notice the equations that form your parametric, there's 2 of them. There's an x equals t plus 3 and there's a y equals t plus 6 squared plus 1. To get this shape, you would literally plug in points for t, and then you would use your x and your y as your coordinate points. So that's where that shape comes from, okay? Notice it also has arrows. There is direction to parametric functions. They point away from, like, as time increases, your arrows would point to the highest time. So if I had plugged in, let's say I plugged in like t is -2 and -1 and 0 and so on and so forth, my arrows point towards the highest t, okay? And then I'm going to teach you a way to eliminate the parameter. So we eliminate t, and you get an estimation. It's not exact, but you get an estimation of what that graph would look like if it was in rectangular form, meaning squared or cubic or something like that, parabola or cubic or line, something like that. It is more accurate for you to do it the first way because you get the direction. On the second way, you won't know the direction, so you won't see arrows pointing in, and they would be on the ends like a normal parabola, okay? So on the bottom, it says these are continuous functions, meaning there's no stop and start to them, not like a piecewise function, okay? You can actually graph them by starting and not lifting up your pencil. It would be one fluid shape, kind of like your higher degree ones. And then points are plotted in the order of increasing values of t. Again, arrows will indicate the orientation of the curve. Orientation is what the word that they will use to mean you have to put arrows to show which direction it's going, okay? All right, so the plane curve in function notation would say this. If I had f of x and it's going to say x equals, and I had g of x and it's going to say y equals, in both of these there will be a t in some way, and I will plug those points in. And then what I will plot is the result of each of those x and y's, which also can be written as f of t, comma, g of t. And again, these are called parametric equations, and again, t is called the parameter. All right, so you'll get a t chart that's modified because it will now have a third variable. You'll literally have t, and you will plug in points. The result of that will give you your x's and your y's, and then these points at the end are what you will plot to make your shape. Looks like this. Sketch the curve given by the parametric equations. X equals t squared minus 4, and y equals t over 2. And it gives you, it doesn't always, but sometimes it gives you your actual domain. So these are the things you want to plug in, okay? So I want to start at -2 and I want to go to 3. If it doesn't give you something, then we normally do like a -2 to 2, just like typical. So I'm going to start by plugging in -2, -1, 0, 1, 2, and 3 into each of these. So first up is x. I'm going to do x equals -2 squared minus 4. 4 minus 4, which is 0. X equals -1 squared minus 4, which is 1 minus 4, -3. X equals 0 squared minus 4, 0 minus 4, -4. X equals 1 squared minus 4, 1 minus 4, -3. X equals 2 squared minus 4, 4 minus 4, which is 0, and x equals 3 squared minus 4, 9 minus 4, which is 5. And now I repeat that process for y. So y equals t over 2, negative 2 over 2, which is negative 1. Y equals negative 1 over 2, which would stay negative 1/2. Y equals 0 over 2, which is 0. Y equals 1 over 2, 1/2. Y equals 2 over 2, 1. And y equals 3 over 2, 3 over 2, or 1 1/2. Now I'm going to take my x and y's and make my points from the coordinate. Yep.
Would there ever be like ones where like there's like kind of like a rational for the x?
No. No. They're lines, they're squared, they're square roots, but not rational functions. There could be a 1 over x, I guess. Yeah.
I mean, if it's a square root, like what if it ends up with a negative?
You just wouldn't you wouldn't have a point there.
Okay.
So it would restrict your domain.
But I thought like, so would it be a parametric function?
So parametric, it doesn't mean it continues forever in both directions. It just will, once it starts, it will be continuous. Does that make sense? Like it won't start, stop, and then start, stop. But it could have a point and then continue.
So like after that point.
Sure, it could stop in either direction. It just that from start to finish, you won't have breaks. Like it won't be piecewise. You won't have breaks in your function. All right, so now I'm plotting these points. So I made my x and y coordinates, and these are what I'm plotting. I'm plotting 0, negative 1. I'm plotting negative 3, negative 1/2. I'm plotting negative 4, 0. I'm plotting negative 3, 1/2. I'm plotting 0, 1. And I'm plotting 5 and 1 1/2. 1, 2, 3, 4, 5. 1 1/2. And then I'm connecting it. Now, how do I know which direction to draw my arrows? Towards the highest t. So we started with the lowest t being here, right, at 0, negative 1, and the highest t being here. There is no rule on how many arrows you need. You just need arrows to indicate the direction. Away from the smallest t towards the highest t. So if you are given the domain or the range of values for t here, then I would expect everybody's graphs to be the same. But if it doesn't give you that and you are plugging in arbitrary points, like it doesn't necessarily all have to be exactly the same. So like on a quiz or a test, I will give you the values because it makes it easier for me to grade. But in general, it doesn't have to. Like it could be something, you could have gone from -2 to 2 and your shape would be a little bit different. Yep. Okay, so now we're going to learn how to do this with our calculators. So if you remember, we went to the mode to change our mode from function to polar. And that same menu is parametric. All right, so I'm going to mode first because I have to switch it. I'm switching it from that fourth thing in the list that says function, parametric, polar. We're switching to parametric. When you do this, it will change the variable. So like if I hit the x, t, theta, now it gives me t because that's our variable, right? And when you go to y equals, you will see 2 equations for each graph. 1 x equals and 1 y equals. So if I just plot the one that's there, like on this slide, it's 5t, and then it's 10 minus 16t squared. And then when you graph it, you'll see I got like half of a parabola-ish shape, okay? If you wanted to restrict it to something specific, so if we want to do, like, test what we just did, I could plug those equations in. Let's clear this out. What's the first one? T squared minus 4, right? Yeah. T squared minus 4. And the second one is t over 2. And I graph it. And what you see here is only the top part, right? Because we didn't restrict this window to be the same. If I go to window, I want to restrict the t is what we're restricting. And it was from, what do we do? Thank you. -2 to 3. Now it should match what we got. Good? Questions? All right, so example 2, sketch the curve given by the parametric equations. This time your values are -1 to 3/2. So it doesn't mean you have to go in like equal increments. Like if obviously there's going to be a fraction there at some point, but you could avoid it until you have to have it. So I could start with -1, I could do 0, I could do 1, and I could do 3/2. They obviously, if it was like looking at something symmetric, it wouldn't happen because of that 3/2 is not the same distance. But you don't have to go in fractional increments just because they give you a fraction. You just have to make sure you include it at the end. And notice I don't even need these boxes, okay? As long as you can get your curve, I would say stick to whole numbers for as long as you can. All right, you do it. All right, I plugged them in. -1, I got 0, -1. 0, -4, 0, 1, 0, 1, and then 3/2, 5, and 3/2. So I go 0, -1, -4, 0, 0, 1, and 5, 1, 2, 3, 4, 5, and 1.5. And again, we point our arrows towards the bigger T. So it should look something like that. Questions? Okay, that is one of the 3 things you're going to learn in parametric. The second is this, which is eliminating the parameter. By eliminating the parameter, we are eliminating t. So you're going to take your 2 equations, you're going to solve one for t, and then you're going to plug that into the second one, and it will eliminate your t. These graphs are approximations of them. So what we did the first time, they are more accurate, okay, because you will have direction. These won't. These will be approximations of what that graph looks like. So we're going to, again, take one of the equations, solve it for t. You get to choose. Hopefully one's easier than the other, but it doesn't really matter. Solve one for t. Then you're going to take whatever that expression is, and you're going to plug it into the other equation in place of t, just like we do with substitution. Then when you're graphing, you're going to use, obviously you'll lose the orientation of the graph, and lastly, the domain of the function may need to be restricted to graph accurately. So you're going to get things like square roots and stuff that one you would have to restrict your domain to get. All right, so we're going to graph by eliminating the parameter. So x equals t squared minus 4 and y equals 1/2 t. Which of these two is easier to isolate the t? 1/2. So I'm going to take this, multiply both sides by 2, and I get t equals 2y. Then I'm going to take that and plug it back in to this one in the place of t. So I get x equals 2y squared minus 4. And I get x equals 4y squared minus 4. Now this goes back to conics, which we are going to review conic, like this is actually tomorrow's section. So I don't expect you to remember this solid, okay? But tomorrow we're going to go back over what happens when the y is squared. What happens to my graph? If it's squared, it's a parabola, but if it's y squared, turn to the right or to the left, okay? So if you don't remember, which you're going to be reminded of this tomorrow because that's what tomorrow's section is, but the goal here would be to isolate the squared term, okay? And so we put this in a format that's like standard form is the y plus or minus, y minus k squared equals 4px minus h. Do you remember this from algebra 2? Yes, yeah. So what you need to understand is that it's turned sideways. If you didn't remember it, you could always plot some points to get an estimate, okay? But if you do remember that format, then it's going to help you graph easier. So to do that, the y squared can't have a 4 on it, okay? Which means I would add this 4. So x plus 4 would equal 4y squared. And then I would divide by 4 or multiply by a 4th. And this is standard form of a parabola. Again, we will get more into that tomorrow.
Wait, why are we putting
Because you needed to graph this now.
Why would it be 1 4? Wouldn't it be 1?
No, you're dividing by 4 here. So you have to either divide everything by 4 or multiply by a fourth. And standard form, this can't be distributed. It has to be out front.
But like say 4.
Yeah, that's the 4p though. This is standard form. Now to get the information out of it, what follows x is the x, the opposite, is your x coordinate of your vertex, which is -4. What follows y would be the y coordinate of your vertex, which is 0. So that tells me that already I know -4, 0, 1, 2, 3, 4. Here is my vertex.
How'd you get -4?
Because it's always the opposite. The parentheses are always x minus or y minus.
How'd you get the y?
There's nothing after y.
And then for like to get p.
So to be honest, today I don't expect you to get more accurate than just knowing which direction it goes. Tomorrow will be a little bit more accurate. But what I need you to know is if it's y squared, it goes to the right or the left, right? And if it's positive, that 4p is positive, it goes to the right. If it was negative, it goes to the left. So because we're just approximating these graphs, you could simply draw yourself a parabola pointing to the right, okay? Tomorrow we will get into more specific details on parabolas and circles. But for now, that's what I would expect you to be able to do. Yeah. P is the distance from the vertex to the directrix and the vertex to the focus.
And then you would set 1 point.
Yep. Yeah. And we'll do that tomorrow. For right now, you just kind of need to know the general shape of this. And again, notice we don't have arrows because we don't know our t. We don't know if it got bigger in which direction, okay? All right, example 4, eliminate the parameter. So this time I get y equals t squared minus 2 and x equals t minus 1. Pick one to solve for t.
T minus 1.
Okay, so this one, I would just add the 1. And I get t equals x plus 1. And then I'm going to take this and I'm going to plug it into the t. Y equals x plus 1 squared minus 2. What kind of shape is this? It's a parabola. Which direction? It would be up or down, right? So we don't know yet until we make sure that whatever squared is on the side by itself. So to do that, I'm going to add the 2. And I get y plus 2 equals x plus 1 squared.
You don't distribute the
Well, or you could keep it, if you wanted to, if you could keep it this way. Let's talk about transformations because we haven't gotten into conics. Let's try it with transformations. We know that's an x squared, which means it points up or down, right? What's the plus 1 do on the inside? Left 1. What's the minus 2 on the outside? Down 2. So I can go left 1, down 2, plot my vertex, and we know it's positive, so it points up. Questions on that one?
and you don't need like 3 points.
No, just these are just approximations.
Well, you could just do the top thing, right?
Like up and out one, you mean? Yeah, but you don't even need to do, I mean, you can, but you don't need to. You're literally just doing an approximation. Okay, the last thing we're going to do is work backwards. We are going to be given 2 equations without the variable. No, sorry, you're going to be given 1 equation without t and 1 equation with t. And the goal is to bring the t back in. So this is finding a parametric equation if you are given 1 rectangular and 1 parametric. So you're going to look at the 2 equations you're given. Only one of them has the t. You're going to solve for the other variable. So it could be an x with a t or it could be a y with a t. But you're going to solve for the other variable. And then in your rectangular equation, you're going to plug that expression in. And you'll end up with 2 equations, 1 x equals, 1 y equals, with both having a t. So the answer to this is a parametric equation where somewhere in here, there's a t for both of those, okay? Again, you'll be given 1 without the t, 1 with the t. So you're giving 1 rectangular and 1 parametric. And you have to create the second parametric. So it would look like this. Find the set of parametric equations to represent the graph of y equals 1 minus x squared using the parameter x equals t. If this was not solved for t or for x, then the first thing I would do is solve it for whichever x, either x or y, whichever one you have. And then I take it and I plug it back into the rectangular one, the one that does not have the t. So y equals 1 minus t squared. And this one is as simple as that. My answer is both of these equations. Usually it's x equals and y equals. And it looks like that.
So that's the same.
That's it.
What does the T stand for?
T is time. So it's you're going in a direction, like an orientation is what they call it, but it basically means what's happening over time. Okay, the last one, same set of instructions. It says find a set of parametric equations to represent the graph of, and again, it starts the same. What's different this time is my parametric part of this. T equals 1 minus x. So x is the variable that is there that's rectangular. I want to solve for it. So I can either subtract the 1 and then change the signs. Or I could have added the t and added the x and subtract the t. Like how you do that is fine. It doesn't matter. And you can even switch this and make it x equals 1 minus t so that when it plugs in, it's easier. Now I've solved for x. I'm going to take this and I'm going to plug it into the other equation. And this time I'm going to expand it out. So if it was my parabola and I'm dealing with x's and y's, I would keep it that way because it's more in standard form with transformations. But if it's like this, you're going to actually expand this out. So I get y equals 1 minus, the shortcut to squaring is square the first one, square the last one, and double the product. Or expand and FOIL it out, same thing. And then distribute your negative. And then combine my like terms. So you can either write it like that, or you could write it as negative t squared plus 2t. Either of these is fine. But your answer is that and the other one that already had t in it. And solved for the x. So I'm going to say this is 1, x equals 1 minus t, and y equals 2t minus t squared, or negative t squared plus 2t. Like the order there doesn't matter. But you do want to give them as y equals and x equals format. Here, I distributed this, so then I got 1 minus 1, so they canceled out. So the wording on this question on WebAssign is weird. It gives it to you as like A and B, but it's really two separate questions. So I don't know if you want to open up your WebAssign. You can look at what I'm talking about. It basically just gives you this as your instructions. And then it would say A is this and B is, let's say, for example, the one we just did, like that. Those are two different questions. It's just you have the same rectangular to start with, and then you have two different parametrics. But they do give it to you as like A and B, so it looks almost like they're the same question. It's two different questions. Questions for me? All right, so homework, and it's going to be like this for the next 4 sections, is on WebAssign. There are graphs involved. You need to make sure that you hand draw the graphs, and then they're multiple choice, obviously, then make your selection. But make sure that in the work that you are submitting and turning into me, that your graphs are hand drawn. As a reminder, you need to screenshot the results of WebAssign. You need all boxes visible. So if there's 10 questions, I expect to see all 10 boxes. The easiest way to do that is split your screen between WebAssign and Notability. It will shrink it. It makes it one box, okay? And then you're obviously submitting that with the work. So work, WebAssign results. And if there's graphs, you need to make sure you graph by hand. Questions for me? Okay.